I don't even want to say regional. I mean, even along a reef tract, we're seeing differences in responses from one reef to another, or within one reef area. How do we respond to that? How do we adapt to that? How do we plan for restoration and you know, of these? Because it's not just one. There's not going to be one answer to restorations. It's going to vary from one location to another.
Yeah, Shirley, I'm going to be bringing this out in my talk, and I don't want it to seem like I disagree with you, because I fully agree with you. But I see the solutions being at the local level, at the regional level, and at the global scale. And I'm going to mention some of that. And I think the tools that we now have available to us help us understand that at the regional scale. But I think in applying the science and to understand the tools we need to be done at the local level. And I think the local level is where we get our most the information that we can use to take to those that can help us make
to inform the decisions that are going to be made at
exactly.
You know, at that level, but also to inform our funding agencies on the priorities for the research that needs to be supported as well.
So when you hear me talk,
yeah, no, it's supported. Yeah,
we're still in agreement.
I saw two other hands that didn't get addressed over here.
Yeah, maybe to kind of switch things up a little bit, and not to detract from the importance of coral reefs and the Florida reef tract, but we've heard, I think, some signs of it in some of the talks that the importance of seagrasses and the buffering capacity to some of these ecosystems. I haven't heard much on, you know, a fairly significant data gap in the state of Florida from a lot of these talks. The Big Bend region, and your contiguous seagrass beds extending throughout that region that could offer some buffering capacity, resiliency to the overall Gulf Coast of Florida. And I haven't really heard too much of what we're doing to focus on overall comprehensive research and monitoring program in the state. And maybe, Kim, you could touch on it with the SECOR network, if there's efforts to extend some funding to support research in areas like that that might provide some key resilient habitats for the state of Florida in the future.
With respect to the monitoring efforts, I think there are definitely some grassroots efforts that are spinning up. For example, as you know, in Tampa Bay, we have EPA now supporting establishing an Ocean Acidification monitoring network in Tampa Bay. We've discussed in that area expanding that with the assistance of folks like Sea Grant to a statewide monitoring program. There's a lot of groundwork that has to be laid to do that, and a lot of coordination efforts, and we need to get more than just some of the local entities involved in that, so that we can be gathering data that we can actually compare across the state. With respect to the seagrasses, I think, Chris, you were involved in Derek's study, right, as well. And seagrasses are an important resource that we need to take a look at, because they do have the ability to buffer pH. What we don't know is what that balance is between pH buffering while they're photosynthesizing and CO2 respiration as they're dying off and degrading. And so, you know, while we might have great buffering during portions of the year, we could also have exacerbation of decreased pH during die-off times. And so that's one of the aspects of this that we have to take a look at. Florida's really interesting because we are a carbonate platform, as I just got done telling you. And so even though we do get CO2 production during these die-off periods, we also have a lot of carbonate sediment that dissolves and buffers that. And so there's a very complicated interplay between the biological and geological interactions that's very different here than in other regions. And so these are things that are relatively unique to Florida, things that we need to study. But we do, I think, generally feel like that it is not all doom and gloom, because we have some areas that may actually help with refuges for organisms from ocean acidification. We're also finding, one of the slides that I showed you, that some of the mangrove areas in very unique circumstances may also provide refuge for corals, both from thermal warming, bleaching, and ocean acidification. And so, you know, in that spectrum of habitats that we need to be looking at, and at those scales, you know, we really need to look at that whole gradient from areas that are really suffering, like some of our basically dead reefs, to areas that are thriving, and areas that look like sort of novel ecosystem transitions where ecosystem populations are changing in ways that we haven't seen before.
Kim, your question, you know, your answer to to the buffering capacity of our carbonate sediments led me just to, that was what I was curious about. How well are our carbonate sediments either masking or mitigating or interplaying with the overall increase in CO2 in the water and the atmosphere? And how, is it buying us time? How are you addressing that fortunate capacity, at least regionally, with the ability for the carbonate sediments to help mitigate, the changes in the buffering capacity of pH in our waters? Are you looking at that? Is that being addressed? And is there anything you can tell us where that is leading?
We are beginning to look at that, and some of the data that Chris showed you actually helps answer some of those questions. The ability of carbonates to dissolve and buffer seawater chemistry and those chemical changes rely very heavily on hydrodynamics, or movement of water and water mass residence times. And so we think in places where you have a longer water mass residence time and a longer amount of time for those kinds of chemical interactions to take place and change the water chemistry, that you may see some buffering from that. In other areas that are well flushed with oceanic water, that water doesn't reside over that substrate long enough to be drastically affected by those chemical changes. And so we can look at those things from a regional scale, but that regional scale and that ocean chemistry at a regional scale really provides the boundary conditions for those localized areas where we might see some of these factors helping buffer ocean acidification and pH. And one of the interesting things about Chris's talk is you can see that at that regional scale of the Florida Keys, you can see some of those interactions already taking place. And so we know, at least at the sub-regional scale, we may be seeing some of these chemical changes that help create these buffering environments. And those are even more so at smaller and smaller scales. For example, some of the seagrass beds in the Florida Keys, upstream of those, when you have water flowing across a seagrass bed, upstream of that seagrass bed where corals are growing, they have no benefit from seagrass changing pH. But just a few meters downstream where corals are growing, they're actually getting that benefit. And so those spatial scales are very important.
Now, at this time, because we're getting short and I want to kind of allow everyone time to take a long enough break, do any of the panelists have final 1-2 minute thoughts that you'd like to share on any of the points that were raised? I think we've set up the next panel very nicely to start thinking about what activities are going to start closing these data gaps. But I don't know if any of you want to sound off on that or anything else that occurred to you.
I just wanted to mention that we've only been talking about ocean acidification this morning, but we really need to think about it in the context of warming, because the two are happening simultaneously. And our research needs to focus on the interaction between those two factors. And the limited amount of work that's been done to date shows really strong synergies between the two. So just as an example, everything we know about bleaching has been conducted under present-day CO2 levels. But we don't know what the temperature, the bleaching threshold temperature for corals will be in a world where the CO2 is double or triple what it is today. And the few experiments that have been done suggest that the bleaching threshold temperature could be lowered by several degrees at the same time that the environmental temperature is rising by 2 to 3 degrees. That could be catastrophic if that happens.
I think just the take-home messages that I've gotten out of the discussions that we've had this morning are that I think the first and foremost needs to be an integrated approach. So we need to think about a variety of physical, chemical, biological factors. When we do our experiments, we need to consider a variety of organisms and how they interact with one another, and not just isolated species. And when we do our experiments, and that the scale of variability is, for me at least, thinking about this, is much finer than what I had originally considered. So I think kind of thinking about an integrated approach, thinking about the scale of variability, for me are the two take-home messages from our discussions.
And I'd just like to reiterate Chris's point a little bit in the context of disease, because even if lowering pH does reduce some virulence of the diseases out there, as water temperatures warm, we know most of the research that has been conducted on diseases thus far is that temperature is a significant driver of disease dynamics. And so when you have warmer water temperatures, pathogens become more virulent, corals become more stressed, and now with the added stressor of ocean acidification, that could significantly impact the disease susceptibility, disease prevalence that we see within our reefs off of Florida, within seagrasses, within lots of different organisms besides corals as well.
I just want to close by reiterating on the integrated science approach. You know, ocean acidification is very difficult because it spans so many disciplines, and no one person and no one group can fully understand it from a system level or an ecosystem approach. And so as we get into the afternoon, one of the most important things we can do is very carefully and very smartly frame research questions and then organize groups to collectively address those research questions. That's the only way we're going to make good progress. You know, scientists are very interested in numbers of things, and we're kind of like squirrels. You know, we see a we see a nut in a different area, and we look, oh look, it's a squirrel. You know, and we need to stay on track, recognize the important issues, and really organize and focus on bringing the science to a conclusion to answer questions from both the scientific and societal aspects of this problem.
Thank you. Let's thank all the speakers for a great presentation. Thank you. So we're going to reconvene at 11:15. There's coffee and snacks, and we have not gotten word yet that the plumbing has been fixed, so you'll have to cross the street to use the, wait, second floor. Second floor. Okay, second floor restrooms are working. That's great news. Okay, so see you in a few minutes. Thank you so much.